Thank you, Jen. All right, welcome. Thank you, everybody, for being here. My name is Carlos Arguelles. I'm a senior principal engineer in Amazon Worldwide Stores. And I'm here to talk about inflection points that I got to see throughout my time at Amazon. And it was an interesting time because the company grew by about 3,000% while I was there. So lots of interesting little turns and so forth. But first I'm going to talk about Thanksgiving. We've got Thanksgiving coming up pretty soon in just a couple of weeks. And for those of you who are not from the US that are visiting from other places, there's three things that we do. First, we eat massive amounts of turkey and really unhealthy food with our family. Second, we pass out in a food-induced coma after eating all that crap. And then when we wake up, we do Christmas shopping. Welcome to Black Friday. It is one of the busiest shopping days of the year for Amazon, as is Cyber Monday and Prime Day. So if you are in the Amazon Worldwide Stores, like these are really big deals. Black Friday, Cyber Monday, Prime Day, and so forth. So I'm going to take you back in time to 2011. I was a youthful SDE2. I had hair, and I was feeling like I'd been at Amazon for a couple of years. I started in 2009, and so by 2011, I was feeling that I was feeling comfortable with my role, and I was feeling good, and I was beginning to pursue a senior engineer promotion. And I own a service kind of like this, just at a very high level. There's the Amazon retail site, and it was sending a bunch of information to my service. We were putting that in S3, and we were processing petabytes of data on just a bunch of, at the time, it was a bunch of MapReduce jobs. And the data from all that was going back and feeding a bunch of critical services in the Amazon store. So really fun thing. And as Black Friday was coming, I made a list of everything that I needed to be testing or that people around me needed to be testing. So big long list of like, here's the things that we should be testing. And then I costed everything and I figured out, here's the things that we can get done. And here's the things that are definitely not getting done. And I drew that line. And load and performance testing was below the line. It was the thing that was immediately below the line. I had one more pitch. I went to my director and I said, hey, this is Amazon. I think we're going to get a lot of customers on Black Friday. Like, we should be doing this. And he said, well, how long is it going to take to do this? Well, probably 2 months to do it right. And he said, no, we don't have time for this. There's 1,000 things that we need to be doing, and it doesn't look like it's very risky for this particular architecture. Let's go for it. Sure enough, Black Friday comes along, and the first thing that we noticed was our service was underscaled, which is not a big deal, but all these alarms are going off and all these pages are going off, and this is before the days of EC2 and being able to auto-scale, so we're frantically running around the building and getting hardware, and we added hardware. So good, crisis averted, right? No, not quite, because all we did is we just pushed that load further into the stack, and all these additional hosts were just running we're writing additional pieces of metadata to a database. And this is before the days of DynamoDB and so forth. This was a good old-fashioned Oracle database running on a good old-fashioned piece of metal, and it failed miserably. And when it did, the whole thing started failing because my service couldn't write to this piece of metadata, started rejecting requests. It stopped answering requests. And so the retail site flew blind for 8 hours during the busiest shopping day of the year in 2012. It was my fault. So the next morning, a one-on-one shows up with my director, and I'm thinking, cool, this is the day I get fired, because I just cost the company multiple millions of dollars in an operational issue. And for the first 10 minutes, he's asking me all kinds of questions, trying to understand how did this happen, what things we could have done to prevent it, and so forth. And after about 15 minutes of a lot of really hard questions and me sweating, he just sat back and he said, cool, how are you going to prevent this from ever happening again? And I thought, cool, I'm not getting fired. That's good news. But then I thought, this is actually hard work. I have to go build all this infrastructure to do proper load and performance testing against my service. And and I went ahead and did that but the thing is, this was an inflection point, because before that day, I had gone to my director and I had said, we need to be building all this infrastructure. And he has said, no, we don't have time for this. After a multi-million-dollar operational problem, we sure had time for that. So that's what I mean by an inflection point. So my first piece of advice is don't ever waste a great crisis. And that was a turning point for me, for my career, and also for a lot of infrastructure at Amazon. So now that I've told you that little story, what I've done, I started at Microsoft back in '97. I was in various parts of engineering productivity in Microsoft Office and Microsoft Windows. I was there for 11 years and 3 months. And then in 2009, I joined a little company called Amazon. And I also spent 11 years and 3 months at Amazon until 2020. In 2014, I became the principal engineer responsible for Builder Tools. And Builder Tools is all the tooling that Amazon engineers use internally to do source control, building, deploying, testing, all of those things. We have all kinds of internal tools for doing that. And I worked in that team for about 6 years. I was the lead for infrastructure, company-wide infrastructure for integration testing. And then I went over to Google and I met Jen. And there I also was a technical lead for infrastructure, company-wide infrastructure for integration testing. So the infrastructure that tens of thousands of Googlers use to create test environments, run integration tests, and so forth. Same role, very different companies and very different technologies, and I'll talk a little bit about that. And about 6 months ago, I decided, Google has been fun, but Amazon is my home, and that's where I want to come back to. And so I came back about 6 months ago. So that's been my journey. And today I want to talk mostly about this period, because the last couple of years have been in flat headcount for the vast majority of the tech industry, but 2009 to 2020 was kind of a crazy time. How crazy, might you ask? Well, so in terms of engineers, when I started, we were less than 3,000 engineers, which felt like a big company, but looking back, when I left, we were 80,000. So that's about a 3,000% growth in just engineers. By all accounts, market cap back then was 32 billion, which seemed like a lot of money. It's 2.2 trillion today. In case you're wondering, I don't have any of that 2009 stock, because if I did, I wouldn't be here today. I would be drinking pina coladas on a beach somewhere. So do not take financial advice from me. But it was good times. And I got to grow with the company. So I started as an SD2. 3 years later, I got promoted to senior engineer. 3 years later, I got promoted to principal engineer. And when I got rehired as senior principal. So it's been fun to grow up with the company as the company was also growing up. So 2009 Amazon is more like an adolescent Amazon. And 2024 Amazon is more like a more grown-up Amazon. So the main thing that I want you to take away from this talk today is that there's inflection points where investments in engineering productivity become feasible when before that point they weren't. I want you to be able to recognize some of the patterns, and I want to encourage you to seize the day and actually push for those things. So the most obvious inflection point is number of engineers. That's a very clear one. You can see the company growing from 3,000 to 6,000 to 20,000 to 50,000 and so forth. And at any one of these points, things that didn't really matter before, now they actually matter a whole bunch. So that's what I mean by that is 3,000, maybe some amount of toil, we just kind of ignore it, but little bits of toil really add up at 50,000, 80,000. Google is 120,000 engineers. It's mind-boggling how much this little bit of toil really adds up. And that's the thing that empowers us to build a lot of the things that we build for engineering productivity. So the framework that I use is usually this when I'm thinking about, should we make this kind of investment in engineering productivity? Well, how much toil are we talking about? How often does it happen? And how many people does it affect? And I'll give you an example of that. A couple months ago, I had somebody coming up to me, and this is audience participation. I don't have any financial reward for you, But if you get this number right, you have my admiration and respect. Somebody came to me and they were annoyed because there was something that took about 10 seconds to do. It was just this annoying manual thing, and it took 10 seconds to do. And so we sat down and we went through my little back of the napkin calculator to kind of figure out, like, how much money are we wasting? You know, what kind of productivity are we talking about here that is affected by this 10 seconds? Well, how often do you see this happen? Well, you know, maybe 5 times a week. And you know, how many people do we think it affects? Probably about 100,000. So engineers, TPMs, and so forth. So how many SD years do you think are we wasting with, you know, this 10 seconds?
8.
How many?
8 years.
8? Okay, keep going. 20? Keep going.
100.
35. So at Amazon scale, a 10-second silly little thing that you have to do every single day amounts to 35 SD years of productivity on the table. It's not just the amount of money that we're wasting, but actually, like, those engineers could be doing something more interesting and more valuable for the company. So that's the kind of, like, really cool thing that comes with scale. And so this engineer and I were talking, and you know, my next question was, well, how long is it going to take you to automate this away? He said 2 months. All right, so all of us engineers are overly optimistic about our ability to meet deadlines. So I said, 2 months, cool. That's going to take you 4 months. And then, you know, once you put a piece of code in production, you have to operate it. So, you know, over the course of 5 years, there'll be operations and PagerDuty and you know, software upgrades and all kinds of things. So let's throw in another 2 months for, you know, operations over the longer term. So that's probably going to take about half an SDE year to do this thing. But you know what? If it can save 35 years of productivity, that's a pretty good investment. Let's go ahead and do it. But the story's even better because I just talked about the year 1, but you have to remember that this compounds over time. So if you remove some, you know, ridiculous toil that everybody had, you know, over the course of 5 years with flat headcount, that's 174 SD years because it's just, you know, 35 times 5. But if you're in hypergrowth, if the company's doubling in size every year, well, first year is 35, second year is 70, third year is 140, like, that really adds up. And a lot of the investments we're able to make at Amazon were based on that kind of growth that made some things more reasonable to do. I know that measuring engineering productivity is pretty intangible. I think a lot of us feel kind of hopeless. I recommend this book to you. I think it's great. It's called How to Measure Anything. And it helped me think about how to measure a lot of things in engineering productivity that feel intangible. How much time is somebody wasting on something? How much time is the whole company wasting on something? This is a great book to start thinking about that, because I think we often give up too early, and we could at least have a sense of, you know, maybe that 35 is not 100% correct. Maybe it's 20, maybe it's 50 years. But you know what? It's a lot more than half a year. So that gives me a ballpark so that I know, is this a sensible investment? So that's one inflection point, but that's not the only inflection point that you can have. Another one is a crisis, of course. And I talked a little bit about that at the beginning with my horror story. Anybody know who this is? Who's that? Oh, not quite. That's a good guess, though.
Taylor Swift?
Taylor Swift? Yes, that's Taylor Swift. And this is the 2018, I think, world premiere of You've Gotta Calm Down. And the reason this was important to me is because she chose Amazon Prime Music, or Amazon Prime Video, to live stream that world premiere. We got some Amazon Music people here. And I was pretty nervous because she happens to have a few fans, right? And this is a pretty high stakes event. We were expecting tens of millions of people to all live stream at the same time. And they used my little technology that I had written because of that horrible operational issue in 2011. to validate that they could handle tens of millions of users live streaming. So it was a pretty cool kind of journey from there, from this operational issue to being responsible for making sure that we can live stream to 40 million people. And so the way it happened was I wrote a bunch of infrastructure for my team because I needed it, because I wanted to redeem myself. And I was able to prevent and mitigate a bunch of issues in 2012. And then I thought, maybe other people should be doing this sort of thing. And I started sharing that infrastructure that I built, all the tools, and then 2 teams started using it, and then 10 and 100. It was still kind of my pet project and weekend project, and eventually 1,000 different services were using it, and then it became my day job. And then 10,000 services were using it. It became the day job of many other engineers around me. And at some point, it became the Amazon-wide load and performance testing infrastructure that we use for things like Taylor Swift and launching AWS services and so forth. And so that all started with a crisis, with a personal crisis and with a work crisis. And so never underestimate a good crisis as an inflection point for engineering productivity. Sometimes the inflection point is maturity. And so let me give an example of what I mean by that is all these big companies, Amazon, Microsoft, Google, Meta, they'll have a tremendous amount of duplication in engineering productivity tools. It's the bane of my existence because I'm strongly opposed to duplication. But it happens. Big companies do that. And I think there's 2 reasons why, 2 valid reasons for doing that. The first one is, if you are in a period of hypergrowth, you have to move fast and you have to move independently of everybody else. So I think under those circumstances, each organization will optimize for what they need to get to market. And I think that makes sense, even though it personally pains me to see duplication. The other one is that there are times in life where there's a huge amount of ambiguity. We are in one today with Gen AI. I don't know how Gen AI is going to shape engineering productivity. If anybody tells you they know, they're lying. I know that it will. I know that it will significantly change the way that you write code, that you test code, and so forth. But we don't know. So we have dozens of efforts within the company to try to figure out what are the places where Gen AI can really make a difference for us. And I think that makes sense. So when there's ambiguity in a space, sure, let 1,000 flowers bloom and see what happens. But there's also a time and a place for converging on some of those infrastructures. So, and that's another thing that I want to drive is that sometimes the inflection point is converging, not expanding. It's deprecating things, it's removing code, which makes me very happy. So when I rejoined Amazon, I was part of the Amazon Worldwide Stores. And one of the things that was interesting to me is that more and more of our customers are using us on mobile than ever before. And so you can kind of read the trends here that mobile is going to become a lot more important than web. We are no longer a website, we are a store. And most of our customers are using us on mobile. So we have to really revamp and rethink the way that we test or Amazon Store. And as we were thinking about a bunch of infrastructure that we want to build for engineering productivity so that you can provision devices, run tests against those devices, and then return devices back to the pools. You can do that with physical devices through AWS Device Farm. You can do that with virtual devices through emulators and simulators. But we're brainstorming on a bunch of infrastructure that we wanted to build. And before we started to actually build it, I thought, well, this is Amazon. There's a lot of other teams within Amazon that are shipping mobile apps. I should talk to them and see what they did. And sure enough, I got in contact with a bunch of great people in Amazon Prime Video, and they've been doing this for a very long time. They have massive amounts of investments and maturity in their infrastructure that kind of does what we want. I connected with people in Amazon Music. Also, they built a bunch of really cool infrastructure. Of course, teams that are dealing with devices like Alexa and Kindle also have massive amounts of infrastructure. A lot of this is duplicate. And it made sense at the time because all these organizations are moving super fast and getting to market and trying to establish their market. But this is probably a time where it makes more sense for us to learn from each other and converge and so forth. So that's what I've been doing for the last few months is is working across all these different organizations and driving convergence towards kind of a more shared model. And that's a beautiful thing about Amazon too, because as a senior principal, I don't actually care about my specific organization. I act on behalf of Amazon, the company. And so all these different organizations may have their priorities, but my priority is Amazon and what's best for the company. So that's really cool to be able to have a healthy disregard for organizational boundaries. And so, point is, not everybody, not all the inflection points are to expand. Sometimes it's to converge. At Google, when I was the technical lead for infrastructure for integration testing, it was the same thing. There was 4 different infrastructures that grew at Google, completely independently of each other for integration testing. It didn't make any sense. They were completely incompatible with each other, and so we started converging that effort too, and that was my life at Google for a few years. Sometimes the inflection point is operational or engineering excellency. And what do I mean by that? So here's some examples. Back in 2009, I could actually SSH to a production box. It was cool. There was no restrictions on that. I can guarantee you in 2024, you do not want your intern SSH into your EC2 or S3 production environment. So we blocked SSH to hosts. Didn't at the time, right? Like we were smaller, we're moving faster. We didn't have gates like that. But at some point of your engineering and operational excellence and maturity, like you have to start putting some gates. And I think that's a thing that you see as your company grows, as the number of engineers grows. There's a lot more things that can go wrong, and you have to start putting some gates in place. Can you submit code directly? Well, back in 2009, you could. I didn't actually need a code review. I should get a code review. I was told to get a code review, but there was nothing in the repository that was preventing me from just submitting and merging code. We put a blocker on that. So now if you want to submit a piece of code, you have to go through the code review process. The code review process itself makes sure that you get 2 shipments from your 2 closest friends, and then and only then does the code review tool submit the code and merges the code. Google does the same thing, by the way. Maturity thing. All these gates, to some degree, they slow you down. They're obnoxious, but they're necessary, and they become super, super necessary at scale. Should every AWS service have a canary? Absolutely. We run 4 nines and more for SLAs for all of AWS. So in 2018, 2019, I led an effort to get canaries for every single AWS service. You cannot launch an AWS service without a canary because our customers really matter, our availability is super important. You don't have an option. Should you get in code coverage? Yeah, you should. You can decide within your team what code coverage target you want, but I want you to make a deliberate decision as to how much code you want to let go to production that is untested. Again, these are all gates. They're obnoxious. If you're in a smaller company, you can get away without a lot of these, but as your company grows, you have to put more and more gates in place. I can tie a production problem, an operational issue to each one of these, by the way. So that's how we started putting these gates, because we learned from operational issues and we thought, oh yeah, it's probably not a good idea for Joe intern to SSH a production host. We should block that. Sometimes the inflection point is a new market. So for us, being in Builder Tools, my bread and butter was creating engineering productivity for web services. Why wouldn't you want a web service? Everything that Amazon did was web services. Well, not really. We started creating devices. We have software that has to go on those devices, but most of our tooling, most of our CI/CD tooling was very tailored towards web services. So we had to change a lot of the baked-in assumptions so we can accommodate things like mobile phones and Alexas and Kindles. And anybody know what this last thing is? It's a turnstile. It's if you use an Amazon Go store, it's one of those stores where you can walk in, you scan your credit card, then you buy whatever you want, and you just walk out. There's no checkout process. But we have turnstiles, and those turnstiles run software, and we have to test that software. So did I imagine in 2009 that I would be changing our CI/CD infrastructure so that we could test turnstiles? No, I had no idea. My focus was web services, but as your company expands and it gets into other markets, like a lot of the assumptions that you baked into your tooling become invalid, and you have to figure how to widen your horizon a little bit. Lastly, some decisions, and I'm going to do a case study on this one for quite a while here, are really foundational, and they will have ramifications on the way that many other tools around it will shape for generations and generations of engineers. I've known Amazon for 15 years. I've seen many generations of engineers. And it's kind of interesting to see how some of these tools shape up. So here's 2009. We're about 3,000 engineers. AWS was sort of in its infancy. There was foundational services like EC2 and S3, but not much more than that. And the Amazon store was slowly moving away from a monolith. I think we started the move away in 2007. And so back in the days, Amazon was a single binary, very, very large monolith, and called Obidos. And then at some point, it became too hard to compile, too hard to copy to production, too hard to load into memory, too hard to collaborate between engineers because everything was very tightly coupled. And we said, let's bring it up into microservices. This is like super obvious today, but in 2007, it wasn't that obvious. And so we started our long breakup of the Amazon monolith into hundreds and thousands of services. So for example, and this is just 2010, that when you go to an Amazon product detail page, there's between 200 and 300 services that are being called just to construct your page. This 2010, I can tell you, there's a few more than 300 today, just involved in constructing just your Amazon product page, which is super crazy. But the thing that we really wanted to do in 2009 as we started breaking up the monoliths was creating a foundational break and wall between different teams so they couldn't depend on each other's code. That's the whole point of breaking up a monolith. And so the first thing that we did is we created this concept of a two-pizza team, which is a peculiar, weird Amazon term, but you'll hear a lot. But a two-pizza team is essentially the number of engineers that you can feed with 2 pizzas. So hopefully they don't need a lot. It's less than 10. If you got more than 10 engineers, they're going to be pretty hungry with 2 pizzas. So I think somebody in the S team, Jeff, or somebody came up with this term of 2-pizza team, and it was just kind of like this cute term, so it really stuck. So you'll hear this term 2-pizza team when talking to Amazonians all the time. It's just a 6 to 10 person team. So the idea was we're going to break up this monolith into microservices. They have a single purpose in life to do something. And there's a 2-pizza team that single-handedly owns this service. And they need to be able to operate independently from each other. The only communication between these two is going to be through the network, RPC, HTTP, so forth. There's no code shared whatsoever. How are we going to discourage code from being shared? Well, we're going to have micro-repos. So team 1 is going to have its own repo. Team 2 is going to have its own repo. And never shall those 2 repos meet. You want to talk to me? Do it through the network. And this is where we're doing this, monorepo versus multirepo. Show of hands, who's monorepo team here? Who's a fan of monorepo? Couple hands over there. You're Google, come on. Fan. It's a couple. Anybody fan of multirepo? Oh my God, okay, cool. So I did not expect that. We have more fans of multirepo than monorepo. And so Amazon is a multi-repo shop from day one. And because of the fundamental decision in 2007 to start breaking up the monolith and to create these walls, we're very much a multi-repo world. But asking whether you love the monorepo or you love the multi-repo, it's kind of like asking a soccer fan, like, do you love Argentina or do you love Brazil, right? How many soccer fans here? All right. So I'm Argentinian. I was born and raised in Argentina. So you ask me, of course, Messi's the GOAT. But if you ask somebody from Brazil, they're going to have a very different opinion on that, right? So, the whole monorepo versus multi-repo is it's kind of a pointless debate. And what I've learned working 4 years at Google, which is a monorepo world, and my time working at Amazon, which is a multirepo world, is that you're going to have to face and solve complexity. You're just going to have to do it in different places. So it's not that one is going to be better than others. It's just different complexity. So let's go into the software development cycle. You've got some local dev changes, you have a code review, you submit and merge, you deploy some sort of test stage, and then you deploy to production, and that's kind of your standard flow, right? And you're going to test. Hopefully, you're going to test integration tests in each one of these steps, right? If you have some local dev changes, you're going to run integration tests to make sure you're happy. You're going to put it up for code review. Generally, code review tool is going to run a bunch of tests, and then you submit it, merge it, so forth. So multi-repo is kind of like a house with all these different rooms. And you can break one of those repos, and the beautiful thing is that it doesn't break anybody else. And so you're going to piss off your two-pizza team because you're going to break up your tiny little repo, but you're now going to anger the other 80,000 engineers. Whereas, think of a monorepo world as like a studio apartment. You break it, you really break it. Google had 120,000 engineers working on a monorepo, and not only that, but they were pretty gutsy because there were no branches. So everybody's working on head. But they made it work. It's pretty amazing, but to Google's credit, like there's a lot of really smart people that spent a lot of time and massive amounts of infrastructure to make a monorepo with no branches work for 100,000 engineers. And it works, except when it doesn't. There was a couple of times where I couldn't check in a piece of code because, I don't know, some random person had checked another piece of code that made no sense to me. It's like, why am I failing because of this person that I've never met? But for the most part, it worked. But the point is, multi-repos provide kind of this natural, lovely blast radius reduction. And that changes a lot of the equation in terms of engineering productivity because that's kind of a pre-submit world and a post-submit world. And in a place that has a monorepo, the pre-submit world is super important because if you check in, you break the world. So Google and other monorepo shops invested massive amounts to make the pre-submit story really work. So lots of investments in integration testing pre-submit, integration testing against local dev changes, integration testing against code reviews. That is where we put most of our time and energy at Google. Whereas at Amazon, it's not that we didn't want to do that. Of course we want to shift left and catch bugs as early as possible, but having the blast radius reduction in the walls of the repos kind of give us a little bit of breathing room. So we spent a lot more time focusing on things like the kinds of tests that we were going to do post-submit. And so the irony is that Google is amazing pre-submit and fairly mediocre post-submit, and Amazon is fairly mediocre pre-submit and amazing post-submit. So that's kind of a thing that you can see the story kind of play out, right? Like it all started with one thing and kind of led to another and another, and it really influenced the way that we thought about developer tools and so forth. But there's something else that happens. Normally, if you own a microservice, this is your end state is you deploy to production, you're done. But not every single repo is tied to a service. Sometimes a repo, the end stage of a repo is to push to another repo. Why might you do that? Well, at the end of the day, sometimes you have to build a monolith whether you like it or not. Mobile apps are monoliths. You have to compile them, you have to put them in a Play Store. It's a single binary, whether you like it or not. So you have to build some monoliths at some point. You have to assemble large products. And so the way that you do it in the multi-repo world is you have smaller repos flowing into bigger repos, flowing into bigger repos, and kind of cascading like that. So if you break one of the smaller repos and you didn't have gates in place to prevent that piece of code from being pushed to the next repo, it breaks it, and it breaks it, and then it breaks the world. So it is possible to break the world. It's just a lot more difficult. But the kinds of testing that you do before either you deploy to production or before you push another repo, that's super critical because that's your last line of defense before something breaks the world. And so that's why at Amazon that was super important, and we could be slightly more relaxed about the pre-submit story because it wasn't a break the world situation. And then deploying to production was a big deal too. So what kinds of things might you worry the most if you're in a pre-submit Monorepo world? Well, test selection, because out of the billions and billions of tests that exist at Google, what test should I be running for this specific code change? So that's a non-trivial problem. Ephemeral test environment. So I have to be able to spin off a test environment, run my test, and then shut it down. And Google does this extremely well. Hermetic test environments to reduce a lot of the test flakiness. So these ephemeral test environments that I'm spinning on demand, I want to be able to sandbox them so that I don't have flakiness because of the network or because of dependencies that are flaky and so forth. So this is the kind of thing that we invested very heavily in a Monorepo world. I wrote a lot about this, so here's a couple of links if you want to read. I wrote a couple of articles on that. And then, oh, sorry, go ahead. I'm going to run out of time soon, but I figured I'll give you a few pointers here. On the other hand, if you're in a multi-repo world, like here's the things that we cared about. We wanted to have long-lived static test environments with super high fidelity, so we invested in that. Canaries, telemetry, rollback, alarming in production. Those are the things that we're investing on the most, not because we didn't care about hermetic ephemeral test environments, but they're massively expensive to do. Like Google has spent hundreds of engineers for a decade to do this sort of thing. And it's not just testing, so things like vending libraries is really a little bit challenging, so we had to build mechanisms for you to vend a library, because the way you vend a library is you put it from your repo, you promote it to other repos, so you can imagine a situation where one repo is pushing to tens of thousands of repos. So that's a big blast radius. Finding versions. In a Monorepo world, it's much easier to reason about the world because everybody's got the same version. But in a multi-repo world, it's free for all. So if you have a security problem, you have to find out who's using version XYZ of foobar. Then we had to build tooling around that and to keep track of what repos have what versions of what, so that we can go fix that. I wrote about that too. Lots to say about different ways of viewing CI/CD. So there's another link for you. And there's a bunch of links too about just the way that Amazon thinks about CI/CD. There's a couple of articles that my peers wrote about the CI/CD process at Amazon, so I'll point you to that. And my last thought is be deliberate about the kind of proprietary tooling that you end up building for your company versus when you use third-party tools. And I think there's a couple of reasons why it makes sense to write proprietary bespoke tools. The first one is you're trying to do something and the third-party open source tools just don't scale. I built the Amazon Load and Performance Testing infra because in 2012, I couldn't find any open source that could generate hundreds of millions of transactions per second. I needed to do it, so I built it for my company. And sometimes optimizations matter. So Google has their own IDE. They don't sell it. It's an internal tool. But does it make sense for Google to invest like hundreds and hundreds of engineers in their own IDE? Well, it does, because if you've got 120,000 engineers, $400,000 each, and that's just your average SDE2, that's $50 billion a year that Google's spending paying their engineers. So I think that, yeah, investing in an IDE that's going to make your $50 billion a year move a little faster, that's a great use of engineering productivity resources. So I'm a huge fan of the Google IDE. And the last one is that there's an ecosystem effect that compounds. So if you get tools that are working with each other in an ecosystem, that's super powerful versus you're bringing a bunch of third-party tools and they really work with each other. You have to build all the glue for all these tools to talk to each other. That's very difficult, but if you build an ecosystem where everything kind of integrates together, that's really, really powerful. And that's why companies like Amazon and Microsoft and Google, they have massive investments in engineering productivity and internal tools for everything that you could possibly want. My warning is that when we go down this road, there's always the danger of like falling into the bubble, the Amazon bubble, the Google bubble. Like you always have to be aware of what else is going on in the industry. The minute you've created bespoke tools, you're on the hook for advancing those tools along the industry. And I often see that's not the case. Like the industry, maybe 10 years ago, the industry wasn't there. We built something, but we didn't evolve it. And the industry moved. And now we have subpar tools. So that's my warning about proprietary tools. So I have kind of a love-hate relationship. I've spent 27 years building proprietary tools for Microsoft, Amazon, Google, but I have this love-hate relationship with them. So, last thought here, there's inflection points when these engineering productivity investments make sense. There's a number of them that I gave you. Now you know how to recognize them and go seize the day and go do the right thing for, wherever it is that you're working. So,